Now we are discussing about the arc length of parameterized curves. Suppose C is a parameterized curve gamma of t, and we have to find the length of C. For that, we divide the curve C into small pieces like this. Suppose we consider this piece of C and we denote it by delta C. And let these two endpoints are represented by the tips of the position vectors gamma of t and gamma of t plus delta t. Gamma of t and gamma of t plus delta t. If the partitions are very small, then delta t is very small. And if the partition is very small, then delta ck is approximated to a line segment joining gamma of t and gamma of t plus delta t. And we know that the length of such a line segment is given by norm gamma of t plus delta t minus gamma of t. Recall that the norm of a vector v is equal to v1, v2, etc. vn in Rn is given by norm v is equal to root of v1 square plus etc. plus vn square. And if u is any another vector in Rn, then u minus v gives the length of the straight line joining u and v. So using this, we know that norm gamma of t plus delta t minus gamma of t gives the length of this curve delta ck. And if delta t is very small, this value is approximately equal to norm gamma dot of t. It follows from the definition of gamma dot of t. And the length of the curve is approximately equal to norm gamma dot of t delta t. And for obtaining the total length of the curve, we can add the lengths of these small pieces. And we know that results in as delta t tends to 0, the sum becomes the line integral, that we all know. Now we can use these concepts to define the arc length of a parameterized curve. And the arc length of a parameterized curve gamma, starting from the point gamma of t naught, is the function given by s of t is equal to integral t naught to t norm gamma dot of u du. And from this it is clear that s of t naught is equal to 0 and s of t is positive or negative according to whether t is larger or smaller than t naught. If we choose a different starting point gamma of t naught tilde to find the arc length, then also there is no problem because the integral's values differ only by a constant. For if f tilde is the arc length obtained by starting from gamma of t naught tilde, and s is the arc length obtained by starting from gamma of t naught, then we can find of t is equal to integral t naught to t norm gamma dot u du is equal to integral t naught to t naught tilde norm gamma dot of u du plus integral t naught tilde to t norm gamma dot of u du. And since t naught and t naught tilde are fixed points, this integral is a constant. So this becomes a constant plus f tilde of t. Now we can have some examples for finding arc lengths. And we have the example. Calculate the arc length of the catenary gamma of t is equal to t cos ht. Starting at the point 0, 1. The point 0, 1 is the initial point gamma of 0. So the arc length is given by integral 0 to t norm gamma dot of u du. Here the initial point is 0. Then we have gamma dot of t is equal to, by differentiating these terms component wise, we obtain 1, the derivative of cos ht is sin ht. And norm gamma dot of t the whole square is equal to, now that norm gamma dot of t is equal to root of 1 plus sin h square t, and its square is equal to 1 plus sin h square t is equal to cos h square t. Therefore norm gamma dot of t is equal to cos ht. Therefore the arc length is given by s of t is equal to integral 0 to t cos hu du, and that is equal to integral is sin ht, and sin h 0 equal to 0. Therefore the answer is sin ht. Therefore the arc length is sin ht. Now we can have one more example. Find the arc length of the logarithmic spiral gamma of t is equal to e raised to kt cos t e raised to kt sin t. So we have to find the arc length of the logarithmic spiral. Here gamma dot of t is equal to e raised to kt k cos t minus cos t's derivative sin t e raised to kt k sin t plus cos t. And therefore norm gamma dot t the whole square is equal to e raised to 2 kt k cos t minus sin t the whole square plus e raised to 2 kt k sin t plus cos t the whole square. And expanding this and cancelling terms, we finally obtain k square plus 1 e raised to 2 kt. Since cos square t plus sin square t is equal to 1. And here the starting point is not given, so we can consider any starting point. Here we consider gamma of 0 equal to 1 0. Substituting 0 we obtain 1 0, and the arc length is given by s of t equal to integral 0 to t norm gamma dot of u du, and norm gamma dot of t the whole square equal to k square plus 1 e raised to 2 kt, and therefore gamma dot of t is equal to root of k square plus 1 e raised to ku du. And the integral is root of k square plus 1 divided by k e raised to k t minus 1. Like this, we can find the arc lengths of different parameterized curves. Thank you.